Oh, hi there. I'm Eric Rombolabs, and I'd like to tell you about Rombolabs and what we're all about. Rombolabs has many different forms, but today I'm talking about Rombolabs as one of the laboratories within the CLIMB, the Center of Excellence for Limb Loss and Mobility, here at the Puget Sound VA Hospital. As you might imagine, there are way too many topics that we research here to talk about in a video like this, but I just thought I'd give you a little taste of some of our projects. Wouldn't you say so, Elizabeth Russell Esposito?
That's right!
And here's where the magic happens. Let me show you around. Another thing we're very interested in is the rapidly improving technology of virtual reality. What it means for our therapies, but also for understanding the basic fundamentals of how people make sense of their senses. Isn't that right, David?
Yeah!
We're using artificial intelligence to better understand how data from virtual reality can tell us if you're feeling a sense of body ownership over the virtual body, and what that means for your real body. One of our main projects has to do with sensory replacement for prosthetic limbs or other assistive devices. If you lose a limb, you don't just lose the ability to move it, you lose the ability to feel with it. So what we're working on is trying to create a sense of feeling of a replacement limb, of a prosthetic limb. So that looks like devices that can attach with standard prosthesis hardware, or maybe other kind of things like a ski boot. We've got sensory feedback systems, and we show that people can sense where they're stepping on stair steps better. One of the primary areas of my research is trying to better understand the neuroscience of sensation and movement. A big part of that is neuromechanics. That's the shape and the action of biology as it relates to the neuroscience and artificial intelligence of movement. So this is called the ACT hand. It's the anatomically correct test bed hand. And it's a bone and tendon test bed that's been 3D printed from real medical scans that capture all the biomechanics of the hand, but just the tendons and bones. So since then, we've been working on making soft tissues. These are latticed materials that capture the stiffness properties of real biomechanical tissues validated against cadavers. So we're interested in how devices like this can be controlled and how bodies are controlled. Another exciting thing that we're doing next is we're working on miniaturizing the whole thing. This is the version 3 of the Barrett Technologies puck on a motor that you can see is much smaller. So we're always making progress on this. It's a hardware effort, a neuroscience effort, and an artificial intelligence effort. So thanks for listening, and hopefully we'll hear from you soon. Let us know if you want to come by and lend us a hand.